I guess, hello, welcome back. At some point it shut off, I guess. Oops. I don't know, we'll see. Probably it's gonna be a two-part. I'm not sure when it shut off. I don't get notifications when it goes offline, so I guess I'll have to get a second screen to monitor or something. I don't know. Anyway, so what did we do so far? We did the quick review, basic derivatives. Okay, so we did the tangent line problem over here. We did the cool chain rule problem. This was another chain rule problem which we actually turned into a much easier chain rule problem and did a different way. And then implicit differentiation. What else? Yes?
Y equals x, open parentheses, 4x plus 1, and it's 1 over 3.
Exponent? Right. And we're supposed to take the derivative. Okay, good. So we're looking for dy dx. Great. What do we have? We have a product rule and a chain rule. Now, how about we do this problem in 3 ways? Just to well, that's all it comes to mind when I look at it quickly. Probably there's more, but the 3 ways would be what I can think of, you know, immediately. So let's do 3 ways. Let's go with the worst possible way first. And the worst possible way first would be just to do the product rule and the chain rule, right? So to do it the way we would do it at the beginning of the chapter 3. So what should be the color for way 1? Just keep it black, right? Way 1. We are going to do the product rule, and when we have to do the chain rule, it will kick in. Fine. So dy dx is equal to, copy the first. Right? We are dealing here with the uv. So copy the first times the derivative of the second. It's when the chain rule kicks in. Those vultures over there? Yeah.
Yeah, they're always out there.
Always?
Yeah, one time at the classroom back there, they went into the window.
They're so big.
Yeah, they are.
Where was I? Vultures. Oh no, I mean 1/3. Yeah, it tells you how focused I am, right? So copy the first, which is x. The derivative of the second is 1/3 4x plus 1 to the negative 2/3, because we are subtracting 1, times the derivative of the inside, which is 4. That's the chain. That 4 is the chain. Plus, copy the second one, which is 4x plus 1 to the 1/3, times the derivative of the first, which is just 1. Derivative of x is 1. So if you are trying to make sense out of this, you have u, v prime, v, u prime. There we go. So it's all on the pile now. And clearly we need to make this now nice. And the way we make it nice is we do the algebra over here. So I have 4x divided by 3 times 4x plus 1 to the 2/3 plus 1 over 4x plus 1 to the 1/3. And to get the common denominator here, what I need to do is to multiply the second term by 3 4x plus 1 to the 1/3. Because if I do that, I will have the common denominator of 3 4x plus 1 to the 2/3, because 1/3 plus 1/3 is 2/3, and you have the 3 in front. So now what do I have in the numerator? I have 4x plus 3 times 4x plus 1 to the 1/3. There's a 1 missing over here. Now this is not really presentable in this way. So what you can do is you can multiply by 1 more 4x plus 1 to the 1/3. Because that would make this 3/3, and that would make it to be just 3 times 4x plus 1 everything squared. That makes it much better, right? And then in the numerator you will have, you know, more of this stuff to worry about. But you know what? I mean, it can't be perfect. So you pick your poison, right? I really don't care whether it's this one or this one. But that will be the derivative. And that will be the way 1. Now let's take a look at a way 2. Let's say green. Our problem is y equals x 4x plus 1 to the 1/3. What I'm going to do is I'm going to take this x and force it inside. So before I take the derivative, I want to stuff this x inside the cube root. Now, as I force this x inside the cube root, it is going to pick up a cube. Now, this is a technique that you are not used to. You are used to simplifying things. When you see x squared y to the 9th, you go, oh, okay, that's x, y to the 4th, square root of y, right? You are used to this stuff. But you also have to understand that once you have them outside, you can stuff them back in and you will get this. So if you are going backwards, instead of reducing the exponent, you are picking up the exponent. So now, as I am trying to stuff this x back inside the square root, it will pick up the exponent, and it will obviously pick up a cube because it's undergoing a cube. And now it becomes x cubed inside, and I can distribute that, and haha, no more product rule. You still have chain, but at least you got rid of the product rule. So what's your new function to worry about? Is a cube root of 4x to the 4 plus x cubed. That's your new function to take the derivative of. And now you go and you take a derivative. So dy dx is equal to, well, you can first copy this, and then you have your 1/3 4x to the 4 plus x cubed to the negative 2/3 times the derivative of the inside, which is 16x to the 3 plus 3x squared. And should I use the air quotations here? Then you make this pretty, right? dy dx is equal to, you have the long division line, the 3 goes downstairs, the 4x to the 4 plus x cubed to the negative 2/3, no, positive 2/3, sorry, goes down, and then you have your 16x cubed plus 3x squared goes here. Now, the way you stuffed x inside, you can take x cubed common factor, and that's going to go outside, and then deal with things. So let's take a look at that. Now let me see. Yeah, this was not pretty at all. So let's see, so this went in, became this, and then 4x to the 4 plus x cubed, and then when we take the derivative of that, yes, 4x cubed, 4x, so that's 16x cubed. Okay, good. So now what can I do? dy dx is equal to 16, no, first I'm going to kick out x squared and leave it with 16x cubed plus, no, 16x plus 3 divided by 3, and over here I have x cubed that I can kick out, 4x plus 1, everything to the 2/3. So now, as this x cubed goes out, the 3 and 3 will cancel, it becomes x squared. So dy dx is equal to x squared, 16x plus 3, divided by 3x squared, 4x plus 1 to the 2/3. And x squareds die. Now, why is that not the same as the one we had up there? Like this one over here. It bothers me. Because they're supposed to be the same. See, I have 16x plus 3, and over there I don't have 16x plus 3. Because we have the same denominator, so they should be the same. There is mistake somewhere. Let me just check all of the derivatives. So copy the first. Oh, this is the vultures who came in. So copy the first, then 1/3 this to the negative 2/3 times the derivative is 4. Plus, copy the top as is. Do you all see it now? Yep. Algebra. This is why it's good to know multiple ways to do the problem. It's called a fail right there. So this term does not go in denominator. It stays up there because it's a positive 1/3. So I have to fix this. The whole thing is wrong in black. So this stays as 4x plus 1 to the 1/3. Now, what I'm going to do is multiply. So I'm not doing this anymore. Well, technically I'm not doing any of this anymore. This is where you rip the page out. What I need, see, I don't want the common denominator here. I want to multiply and eliminate denominator, right? That's what I want to kill. Or do I? Okay. So I will multiply this side by 4x plus 1 to the 1/3 to get this, to kill the power. On the other side, I need to multiply by 4x plus 1 and then 3 times in front. Does this fix the issue? Let's see. So now the left term is 4x plus 1 to the 1/3 divided by 3 times 4x plus 1. No exponent, because 1/3 plus 2/3 is 3/3, that's 1. So exponent is 1. Plus, and if you take a look on the other side, you have 3 times, there we go, 4x plus 1 to the 4/3, because this is 3/3 here, right? That's, the exponent is 1. So 3/3 plus 1/3 is 4/3, divided by 3, 4x plus 1. Nice. All right, so now I have common denominator. Ooh, if I don't multiply, I can factor. That's better. Kill the numerator here. Leave it in the factored form, and then I can factor it. 4x plus 1 to the 1/3. And then just distribute this, I guess. 12x plus 3, whatever. So now look what I can do. I can take this x to the 1/3 common factor. So 4x plus 1 to the 1/3 common factor. And what's left is 4x plus this is 16x plus 3. Nice. Divided by 3, 4x plus 1. Now, these two can combine into exact answer we have down there. Nice. There we go. Much better. Because it's correct now. So what I did here is I took this guy and this guy common factor. And what's left is 4x plus 12x, which gives me 16x. And then plus 3. And then when that was done, I combined these two guys because I have 1/3 on top and 3/3 on the bottom. So 3/3 minus 1/3 is 2/3. And we write the answer where the larger exponent is, in this case, denominator. So now you see that the black answer and the green answer are the same. Good. So we have 16x plus 3 divided by 3, 4x plus 1 to the 2/3. Whew. So what do I have? I have this problem that really doesn't look that bad, but then it turns out to be bad. Product rule, our chain within the product, right? Then we use some algebra to eliminate product rule and have just the chain rule and deal with that. And now let's go purple, huh? Purple. For the way 3, the function is y equal x, 4x plus 1 to the 1/3. Well, the way 3 is technically just to write the answer out without doing any work, right? Let's use the logarithmic differentiation and be done in one shot without doing any calculations. That's the fastest way. So that would be dy dx is equal to copy the problem as is, which is what we have, times, and now just do the stuff, right? So it's 1 over x plus 1/3, 4 over 4x plus 1, and walk away. Done, right? So that will be the fastest way to do the problem. Now, you might be wondering if this answer is the same as the one we have up there, and the answer is yes, it has to be. Just need to do some algebra to show that, but it must be. The only algebra that you can do in this state is to get the common denominator in this bracket here and get it to work together. So this is equal to x times 4x plus 1 to the 1/3, and then here to get common denominator we need to multiply the left. This over here is 12x plus 3, so it's 12x plus 3, and then need to cross multiply the other side, which is plus 4x divided by the 3x times 4x plus 1, right? That's the stuff together. And now you can see that this x dies over here. Oops. And that gives us 16x over 3. So we have 4x plus 1 to the 1/3 times 16x plus 3 divided by 3, 4x plus 1, which is already this step here, right? And just cancel these things. Well, I can do it here. Into 16x plus 3 over 4x plus 1, 3 in front, and 2/3, which is the same as all other answers before. Yep. So those are the 3 quick ways that come to mind when I see a problem like this. Now, clearly, some of these are a lot of work and others are much less work. I would actually use, even though logarithmic differentiation is close to my heart, I always like logarithmic differentiation, I would use green. That's why I picked the green color here, because it's such a crazy way to do the problem where, you know, you take the x and you undergo the cube root. That's something that you don't generally do. You are used to simplifying expressions rather than I don't think it's going to be complexifying, good word, because you are actually eliminating product rules. So it is simplification in some sense, because you are killing the entire derivative procedure. But, you know, I would probably, out of all three methods, for this particular problem, I would definitely go with green. But then again, you know, you all know that how much I love implicit logarithmic. And you can see, I mean, look at that. Lot of mess. Green, a lot of mess. And then this, yeah, let's just find one common denominator, right? It's just one common denominator and we're done. So logarithmic differentiation is the most powerful methods of all. And it's tricky, so you have to be careful. It's tricky if you have e to the x floating around. So you have to be very careful about that one. But other than that, the rest of the stuff, you know, once you figure out the pattern, should be extremely quick, and that's that. Hi. Great question. I did it in 3 different ways. Oh yeah, I did mess it up. So. Fine. But you also know that, you know, the way of the sick is to learn enough in one day, kill the master of the living. So that's the idea over here. I'll be better than you at one point. Anyone wants to say something, please? Yeah, no one wants to admit to that one now, because you know what happens if the implicit Lord smells that one, right? Good. Get in your friend. Who will see? I hope you all know what I'm talking about. You don't have to know the details. It's just, you know, just vaguely. All right, good. The rule of 2, anyone? Okay, 1, 2 people, 3 people, okay, good. Any other questions, concerns, problems? Why do you feel bad? Is it okay to have questions, or you want to go home? Apparently they want questions, so yeah, good.
So find the tangent line for 6x.
Oh, we're looking for the tangent line. 6x squared.
Plus 4xy.
Uh-huh.
Plus 4y squared.
Uh-huh.
Equals 126. And
Yeesh.
0.33.
Good. So if you want to drive someone crazy with these problems, you just give them the line like this with a point that does not correlate. The most terrible things happen. So first of all, you should verify that 3, 3 is on this line. That literally means that whatever this line does, I don't know, there is going to be a location that is 3, 3, and it's on that line. If it's not, this whole thing can fail miserably. So by plugging in 3, you get 9, right? And you compute, and you should get 126. Now let's assume that, you know, author of the problem was conscientious enough to do the, well, why would, just don't trust anyone, all right? 6 times 9 plus 4 times 9 plus another 4 times 9, and that's 14 times 9, and that's 126. Good. All right. Good. So verified. So 3, 3 is definitely on this line, so I can go and find the tangent line and do all of the things. All right, so now what am I going to do? Well, first I need the derivative. And to find the derivative, we are going to do d dx. And I have my 12x plus, there's a product rule right there. Copy the first times derivative of the second plus copy the second times derivative of the first plus the derivative over here equal to 0. A lot of grades go south if you put 126 over there. Derivative of 126 is 0. Derivative of constant is 0. Now, as I said before, compute in this line. There is no reason for you to waste time and solve for the derivative. You are just looking for slope m, so you can plug everything in. At this point, plug in x equals 3, y equals 3, and dy dx equals m. They all plug in at the same time. So what do I have? I have 12 times 3 plus 4 times 3 times m plus 4 times 3 plus 8 times 3 times m is equal to 0. See, it's simplified. So I have 36 plus 12m plus 12 plus 24m equals 0. This is called a boss move. Do you know what the boss move is? When you do something for computation that greatly reduces calculations. You notice that each term is divisible by 12. You have a 0 on the right hand side. Dividing everywhere by 12 makes the calculation a joke. So that's called the boss move. All right. So now, boss move, we have 3 plus m plus 1 plus 2m equals 0. That's end of the boss move. And now we have 3m equal to negative 4, m equals negative 4/3. And we have a 0.33 from before. So now y equal mx plus b, or the other one, whatever makes you happy, right? It's math, you should be happy 100% of the time. So 3 equals negative 4/3 times x is 3 plus b. These guys die. B is 7. And your tangent line is negative 4/3 x plus 7. And happiness. So easy when I do it, right? Yeah, I know. People say, wait, yes. Do you have the problem in mind? Or oh, you can't do this one with that one because it's implicit differentiation. It doesn't work. When you work from a function only, you don't have a function, but it's not a function. This is arbitrary manipulation. So it has a chain rule embedded. And technically, if you want to work that one out, you would add the embedded chain rule to the limit that the function is roughly going to match. So it's not possible. Sorry for disappointing. We traveled all this way. We can do it on something else, but that one would be good. And you don't always want to see it. Unless you want to invent something that would be cool. Green. Everyone else is white paper and you have the green. One question. Any other questions, concerns, problems?
What about like chain rule plus implicit differentiation? Is that a new thing?
This was the chain rule and implicit differentiation. Because every time you take the derivative of y, you get the dy dx.
Okay.
But there is no reason why would that be. Okay, let's make something diabolical. Now that that question is on the table. And the pen said nope. Yeah, the pen just said no. No. I now have two pieces. Nice blinking. I guess he ran out of ink. Okay, so this is how you do troubleshooting, right, in life. Touch screen is not dead because I can use my finger. The pen is blinking, which means battery should be okay. So, as everything else in life that it's Windows, you just restart. And things are still not working. I will put a new battery in. Ah, there we go. All right. So per your request, a diabolical problem that involves implicit differentiation and chain rule. So how about x inverse tangent of y cubed plus 6 equals to 12 what? 12 ln you said? Okay, ln of what? Of what? Well, it has to be something. You can't have ln of nothing. Cube root of x squared. Thank you very much. Excellent. Beautiful problem. Wow. It's not that we just have a chain rule in implicit. We also have it married to the product rule because of this x over here. And then this over here is just a joke. All right. So let's start with just rewriting this problem, because we know that for ln's, exponents can jump in front, right? So this term technically becomes 12 times 2/3 ln of x. And that's just 8 ln x. So we see that that side is not a problem at all, right? Great. So we only need to worry about the scary stuff, actually, which is what you requested. John, right? Good, yes. In your infinite wisdom. So let's do the chain rule within implicit differentiation. Oh, this is not implicit differentiation. Okay, now it is. 6y. It was not implicit differentiation because you can, without this y here, so the original problem, you move 6 to the other side, you divide everything by x, you apply tangent to both sides, you take a cube root. There was a single y that was with the odd exponent. That was not implicit differentiation, but here you go. Put the y over there, problem fixed. All right, so let's go and do this. So what is my problem now? It's x tangent inverse of y cubed plus 6y equals to 8 ln x. So this is the actual problem. We are going to take the derivative d dx. Great. So copy the first, that's x, and then take the derivative of inverse tangent. Well, that's not a problem, right? We know it's 1 plus, and then this is going to be y to the 6 because you have to square the argument. And then you take the derivative of the argument, which is 3y squared, and then you need dy dx there because you took the derivative of y. I'm going to do the whole thing again if you missed it. So the derivative of inverse tangent is 1 over 1 plus x squared, right? So whatever this is, squared. So let's go. 1 plus y cubed squared is y to the 6. And now I need to take the derivative of this, which is 3y squared, that goes on top, times the dy dx, because we were taking the derivative of y in respect to x, plus 6 dy dx, and on the other side is just 8 over x, right? The derivative of ln x, the derivative of ln x is 1 over x, so 8 times 1 over x is just 8 over x. That's the exercise. Now, we factor out dy dx, and what's left is 3xy squared over 1 plus y to the 6 plus 6 is equal to 8 over x. Now I'm not going to divide by this because then I'm going to have a double fraction that will be really bad. What I'm going to do is I'm going to add these terms first. By the way, derivative, calculus over, okay? Calculus over. There's no more calculus. Now it's algebra. And you have options. As I said, you don't want to divide by this because you're going to have double fraction where you have 8 over x divided by the whole thing. So I'm going to add over here. And you just add regular way where you find the common denominator. This is 6 over 1, so the common denominator is 1 plus y to the 6. So you have 3xy squared plus, when you cross multiply, 6 plus 6y to the 6. 8 over x. Nothing adds, nothing combines, nothing cancels. That's it. But I like the fact that I have one fraction because all I can do is a multiply reciprocal on both sides. That's why I wanted one fraction. So, what's the derivative? The derivative is simply 8 over x times 1 plus y to the 6, and then 3xy squared plus 6 plus 6y to the 6. That's why I wanted a single fraction. And now there's the derivative.
That was fun.
Of course, it's math. Math is always fun. Especially when it goes wrong and then you have to figure out what's wrong. Like I had in that earlier problem. Any other questions, concerns, problems, concepts, ideas? Yeah.
I have the last one. Complicated calculation. It's x to the power of x to the power of 6. Yep.
Okay. This is very tricky. This particular problem can be done only by logarithmic differentiation and nothing else. It's just that's what it is. Because we do not have a rule for differentiation. Even forget about 6. Let's just look at it this way. You have a rule for x to the n, and you have a different rule for b to the x. And there is no rule that will, obviously there is a rule for b to the n because those are both numbers, it's a constant, so it's 0, but there is no rule for x to the x. So it's a combination of two worlds, the world of polynomials and the world of exponentials. Nasty combination. So there is no rule that you can memorize there. Now, the way to deal with this is to ln both sides, because then this exponent, right, using our beautiful formula from pre-calc, the exponent p, in this case p is the entire thing, jumps in front. And this crazy problem becomes a product rule, and we can deal with it. Yeah. So what I'm going to do is I'm going to copy this problem. I'm going to leave some space so that I can fit ln's on both sides. And then by the use of the formula, I will have ln y is equal to x to the 6 times ln x. And at this point, I'm going to take the derivative in respect to x. The derivative of ln y is 1 over y dy dx, because we took the derivative of y in respect to x, so we have to follow the chain. On the other side, I have the product rule, so copy the first, derivative of the second, plus copy the second, times derivative of the first, which is 6x to the 5. So we take the derivative implicitly using logarithmic differentiation, so we ln both sides, and then use implicit differentiation. Now, some stuff cancels, some stuff survives. So we have now x to the 5 plus ln 6, and let's just fix this, 6x to the 5 ln x. And now, I hope you see that x to the 5 is common. So, you push y to the other side. So dy dx is equal to y times, you can kick x to the 5 outside and leave with 1 plus 6 ln x. Now y was x to the 6, so the derivative is x to the 6 times x to the 5 times 1 plus 6 ln x. And when you have the same base, exponents add. That's another algebra. X to the 6 plus 5. Thing that we can do. 1 plus 6 ln x. This problem is not trivial. And there are certain problems that can only be done this way. if you have done your homework and if you explored these sections, you would find problems that say find the derivative of sine x raised to the tangent x. There is no technique that you can do other than what I just did to deal with this problem. ln both sides is the only way to put that tangent in front, and then trig would simplify, right? Every time when problem like this showed up on the exam, it was just chaos everywhere. Because everyone is trying to say, oh yeah, the derivative of sine is cosine, and as soon as you say that, the problem is done. Because this is not a product rule or chain rule or anything like that. This is a logarithmic differentiation. And you don't get to start with the derivative of sine is cosine and then have some cute stuff going around, because it doesn't work that way, right? So that's a similar problem that you should be seeing on the homework, and potentially, you know, down the line, exam 3, 4, final or whatever, that you could practice but you should find at least, you know, a few of these in your textbook and the online, obviously. Like that. Okay. Anything else? Yes.
Or whether we have like just like that, like explicit, if we had another layer of explicit, would it be another, would we just go through?
Yes.
Yep.
Nested lns are okay. You can nest as many lns as you want, because every time you take the derivative of ln, it's 1 over ln, and then they'll just have another chain rule. It's not, you can stack these things as much as there is a triple product rule where you have, let's say, e to the x times, so you can develop a formula for any amount, you know, any amount of chains. But you can also develop a formula for x squared e to the x sine x, right? There is something that's called a triple product for that, and so on. So, you know, there are multiple things that you can do in this case. All right? Good. Anything else? No?
Second derivative of what's in the differentiation on that. We're not going to let this do that.
I'm not making you. You can just skip it. Is it? Well, the authors of the book know. I just changed the date. I don't pick the problems, so I'll guess I'll have to honor that on the exam. I guess, I don't know. You didn't like it, you say? Or you are going to label it as too much work? Oh, okay. I know that concept. It's like me going to Mars. All right, great. Well, that was good. See, you can always make it worse. You can always make it worse. That's one of the things. All right, guys. I'll see you in a week. Oops.
Thank you.
You're welcome.